Okay, I am recording now for sure. Okay, I'll keep this window here because please, everyone, please mute yourself. Thank you. Okay, so yeah, so let's start. Okay, so first of all, there is a cycle which we take when we talk about data sciences. So when data is in its raw format, it's just the data. It is not making any sense. It's just out there. It's not making any sense. It is just being collected. It might be collected off some devices. It might be collected off some machines. Um, oh, I don't need the GIF right now. Sorry about that. So, so it might be collected of different things. But when we process that data starts giving us some useful information. And then based on this useful information, we develop a certain kind of a knowledge. And using that knowledge, we can perform some informed actions or we can reach some decisions. So that's what there is a cycle which I wanted to give you some insight into. There is data gets processed and it becomes information. Based of that information, we develop some knowledge, and based of that knowledge, we take some decisions. So next, I'm going to give you an example of this particular cycle. Okay, and then we will have a question and answer session at the end. But let me give you some example based of that. Okay, so for example, you see this table on the extreme left is just a raw data, student and their marks. Student is Asif, marks are 80. Student is Kashif, marks are 90. Student is Alia, marks are 30. And student is Natasha and marks is 65. Just raw data, not making that much sense. In the table that is in the middle right now, I added another column, and this column is just another column, and just by adding another column, see if we can generate some information out of it. So it was the same table till here. It was the same table. Student name and marks. It's the same thing at all. Same thing. Just we added another column called teacher, and see that there is something we can get out of this data. For example, if you check that John, when John is teaching someone, a student's marks are 80. Okay. When John is teaching someone, a student marks were 90. When Jack was teaching someone, student got 30 out of 100, let's assume. Okay. And when Jack was teaching someone, they got 65. So I'm thinking, you know what? So this was the raw data. I processed it, got this information, and this information looks like John is a good teacher because, you know, John is actually, his students are getting good marks, 80 and 90, whereas Jack, his students are getting 30. I mean, this lady, of course, failed. And Natasha, I mean, she didn't do that good as well, maybe a D grade. So Jack is not a good teacher. Okay. So by just adding another column of a teacher, you know, I was able to get some information from the data. So then I do another thing on the third table. I added another table. I added another column, and the column of gender. So can someone unmute themselves? So and then give me some information that they think can be generated from adding another column of gender. Anyone who can unmute themselves.
Males have got good grades or better than females.
Males have got good grade better than female. Very good. Anyone else can get another information? And sorry, I just after this information, I figured out that I might sound biased. I am not. So see what you just gave me information and I didn't realize. Actually, you know what? Let me stop there. That's what data science is all about. You generate information from a data which a company or an owner of a data might not know. And believe me, I swear to Allah, I didn't notice it. The moment you said it, I said, oh, you know what? I seem biased in my slide, you know. So that's what really happens when we talk about, when we do convert data into information. You get to know things which you never knew before, you know. And I was really not planning for this thing to happen, but it just happened, you know. By just adding another thing, another column, I got an information about myself. Hey, while I was bite while making a slide, you know. So that's good. Anyone else can give me another example of another form of information they can think of this? And I have it in the next slide, but I just wanted to check if someone can get another information from this table at extreme right. Anyone? Okay, so let's move forward. By adding just one column of gender, let's see what else we can find. So John is a good teacher. We already knew that. Jack is not a good teacher. That's the information we got from the previous table. But we can observe that John is good with male students. As you can see, when John is um, uh, uh, teaching a male student, they got 80 marks. When John is teaching a male student, they got 90 marks. Jack might be good with, sorry, John is good with male student. Jack might be good with male students, but Jack is definitely not good with female students. As you can see, Jack was teaching Ahmed, and Ahmed got 83 marks. But when Jack was teaching Natasha, she got 65, and Jack was teaching Alia, she got 30 marks. Okay, so by this information, we have developed a knowledge, certain kind of a knowledge, that Jack might not be a good, might not be good with male students, and Jack is definitely not good with the female student. Jack might be good with male students, but definitely not good with female students. So upon analyzing this data, we have to make some decision, okay, some informed decision. So decision could be something like this. Number one, we can simply fire Jack. You know, he's not good with our students. But based on data, we figure out, let's give Jack chance with male students only. You know, because we have figured out that Jack is good with male students, so let us utilize him for male students only. Or let's teach Jack how to work with female students, because I mean, if he's lacking in something, let's do that. Okay. So the thing is, the idea of this slide is that if you go from left to right, you will figure out that how we are transforming a simple form of data into something meaningful by just adding two columns to it. Okay. And just imagine that you have data which is like millions of rows and like 50, 60, 40 columns, you know. Just imagine an amount of information which can be generated from that kind of stuff. Okay, so now the question is, what are the things around us that are generating data? Okay, just think of a home, a modern home right now. What form of data they are generating? We have smart TVs, we have smart hubs, smart electronic sockets, toasters, we have dishwashers, oven. All of these digital things are generating data, and what we call IoT. Collective, all these things are called Internet of Things. I think most of you have heard of this term IoT. All of these things which are generating data and connected to internet from somehow, they are called IoT devices, and they are huge in number. Just imagine a home, a modern home like this in a picture, and all of these things are generating data. But are these the only things that are generating data? No, there are actually, this slide supposed to be come before that. So the thing is, just think of any industry out there in the world: finance, gaming, data security, social media, automotive, robotics, entertainment, e-commerce, education, agriculture, transport, healthcare, astronomy. Name of anything around you, it is generating data. Before that, I was talking to Sahil, one of our participants in the presentation right now. I was giving an example of just a barber shop. Even a barber shop is generating a data. You know, we go to a barber shop and they check us in, right? And then we have to wait. And then when they call us, they click some buttons and they, you know, assign a service provider to us, and we sit there, and then we get services. Even that small industry or a very small thing is generating a data. We can go to them and we can talk to them and we can say, hey, can you give us your data, and we want to analyze this data, and we may come up with a solution, helping that business, telling them, how you can utilize your resources or your hairdressers so that people does not have to wait so much. We might able to figure out some interesting patterns in that thing. So the other question is, what are the different forms of data? So data is not always an Excel sheet, or you can say something in a tabular format, something written out there. It's not just that. Data could be a text form, a data could be an audio form, a data could be a video form, a data could be a picture form. It could be literally anything. Depends on what is the problem we are solving. It depends on that. Data could be anything, right? So the example we are going to take today is more of a textual form of data, but literally data could be anything. Take an example of Alexa. Alexa is a device. If someone have you, most of you might have been interacted with Alexa, or maybe that you just know that people saying Alexa do something, Alexa do something. And there was a news about some days ago, some weeks ago, I heard a news that Alexa called 911 when they figured out that something is happening in the house. Alexa just literally called 911 itself. So what's happening behind the scene? Alexa is also dealing with data, but in this case, Alexa is dealing with data which is in the form of speech. Okay, so that's what Alexa is doing right now. And then when you see in on Facebook, you upload a video and the video has a violence, or maybe a video has a nudity in it. Facebook will automatically stop this video, or it will not stop this video. It will give an option, are you 18 or older? Because this video might contain a violence content. Do you really want to see it? But do you think there are people sitting behind who are hiding these videos? No. There are artificial intelligence models that scientists have already built that analyze data, and then they figured out what is a violence and what is not a violence. Okay, and we are going to do the same thing in this presentation. We are going to analyze the data. It will be in a textual format, but what Facebook does for this was a data in a video format. Okay, so the thing is, the point I'm trying to make here is that data is not only in text format. When we are trying to apply artificial intelligence or data sciences concepts on something, it's not just data in text format. It could be video, audio. If Alexa is doing audio processing, when Facebook is hiding a video, they are doing video processing. And then when Facebook or anyone is trying to detect what is there in a picture, they are doing picture processing. So let me quickly jump to a service that is given to us by Microsoft. There are many services. Microsoft have something called a Vision API. Okay, so what this API does is that you upload a picture to that API. You upload a picture to that API, and then this API will detect what is happening in the picture. So this is one of the examples. So I'm not actually using it. I'm just showing you a picture. So there is a portal from Microsoft. You upload that picture there, and it will tell you there is water, there is someone swimming. It looks like a sport. It looks like a pool. It looks like a person. It might be a man. It might be an ocean. It might be blue. So it gives tags to this picture, and against each tag, what it does is that it gives confidence that I have 0.99% confidence that it's water, and I have 0.95% confidence that it's swimming, and then same way I have 0.6% confidence that it's water sports. So what these models does is, and we are going to see this in action, that when you build a model like this, it gives you a score of accuracy. How much percentage I think my prediction is correct. So that's what we are going to see next. So the question is, why we do machine learning? What is the purpose? So there could be multiple purposes. I have just listed on 4. Sometimes what we have to do is that we have to recognize an interesting data pattern which is not visible with the naked eye. For example, Walmart. Okay, Walmart is generating huge and huge amount of data on daily basis, huge amount of data. People coming in, they are picking up stuff. They have their credit card information. They have their information like, when they swipe a credit card, they can fetch an information who this person is, whether it's a male or a female, and all these things. And they are generating huge amount of data. Once you analyze the data, they might figure out, you know what, on Fridays, two of their products sold the most. For example, apples and battery cells. Okay, they are not related, but this was a kind of a pattern which they never knew before. But upon analyzing the data, they figured out that, these two things, apples and battery cells, are selling the most. There could be any reason for it, but this is something they never knew before. But upon analyzing the data, they figured it out. So they can do any decision on it. They can put apples and battery cells right next to each other. So the customer who comes to pick up apple, based on their data, they know that 80% of them are also picking up battery cells. I don't know why, but they are. So let's put them together so that we can give an ease to a customer. So they can perform any decision based on data. Same way, we can predict action of humans. We can predict events before they happen. And like, for example, there is a huge factory. My father used to work for a factory who manufactured urea. Urea. So he was an instrumentation and control system engineer. And when he used to come back, he used to have this huge loads of data printed on a paper. And we used to use the blank side of a paper as a rough paper, when we have to use rough work. But then I got a hold of that data, and then I figured out that this data is actually generated from a machine. And there was very interesting information, but I was a kid, I never knew that. But I had a few of those data with me, a few of those papers with me till now, and I was looking at that data, and it felt like that if I could perform an analysis on that data, I can predict that by I can find an interesting pattern. Like, for example, when there is Friday and there has been a rain on Thursday, there is a probability of 80% chance that an equipment XYZ might be a failure. Okay, so we can predict, and believe me, if you can predict something for someone, you are a millionaire. Believe me, you are a millionaire. If you can predict of an event with 80 or 90% accuracy that something might happen in future, you can do precautionary measures on that. And believe me, if you can do that, a data scientist or a company of data scientists can do that. They are millionaires. And then we talk about recommendation systems. Like, for example, you go to YouTube, based on your history, YouTube recommend you, what you might be interested in. And I want you to give a test. Most of you might have already observed it, but I still want you to give you a test or something you can do. Open a Facebook app, or just don't open a Facebook app. Just put your phone and talk to someone about a bicycle. Okay, just phone will be sitting next to you, and talk to your friend, your brother, your sister, your mom. Hey, you know what? I feel like getting a bicycle. And your mom will reply, or your friend will reply, oh, which bicycle are you looking for? And you will say, oh, I'm looking for a bicycle. I hope I get a bicycle. You say bicycle 5 times, and suddenly you will see that Facebook will be showing you bicycle ads. So I have observed this many times. I mean, it has stunned me. But I think behind the scene, when we say accept, accept, accept on anything, Facebook is listening behind the scene. And whenever I'm scrolling on Facebook, I'll start getting ads of things which I'm just discussing verbally with someone. So you can test this. I mean, this has amazed me, but somewhere behind the scenes, some voice processing is being happening, and then they get to know that we are interested in bicycle, and it happened to me multiple times. Okay, so now we are digging into something like real. Okay, so now the first step into data sciences. Okay, before that, I was just trying to make basis, and now we are getting into the data sciences. Okay. So I will stop here for a second, and if someone, I was planning questions at the end, but I think we are doing good on time. So if someone have a question, they can unmute themselves and ask something. Let's take one question, whoever comes first. No questions. So it could be two things. I'm doing really good, I'm doing really bad. I don't know. No questions? Okay. So, so there are two types of learning when we talk about machine learning or artificial intelligence. And then again, you know what, I actually had to Google. Someone asked me what is machine learning and what is artificial intelligence, and I give them a funny answer that if you're doing it on the code, then it's machine learning, and if you are doing it on a PowerPoint, it's artificial intelligence. Because you know what, artificial intelligence is a fancy word and looks cool, but there might be a good difference in it, and I'll get that answer. Anyways, so when we talk about machine learning or data sciences, there are two forms of machine learning: a supervised learning and unsupervised learning. So what is supervised learning? Supervised learning is basically done on historic data. Okay, so you do supervised learning on historic data. Uh, you come across the data from somewhere. Okay, you input that data, and then you train a model on that data, and then you do predictions based off that data. Okay, so for example, if I keep on training my model that this is an apple, this is an apple, this is an apple, this is an apple, okay, and then I show my model an apple which is of a different color, but it still looks like an apple, you know, my model will be able to predict with maybe 90% accuracy that it's an apple. But if I show him a bell pepper, you know, bell pepper kind of resembles apple. If you hold them together, kind of resembles an apple. So my system might say that it's an apple, but accuracy might be 0.65%, you know. So, but if I show them a banana, it will definitely say it's not an apple, and it will say it's an apple with an accuracy of 0.0001%, which means that it's not an apple. Okay, so that's what supervised learning is. You feed the data to your model, and then you predict that data. Okay, so you mostly are feeding historical data, and then based on historical data, you try to figure out what we are trying to do. In unsupervised learning, you also feed the data which is coming in, but then the model figured out what could be the different divisions I can divide this data into. Like you just give randomly all the fruits you have, this system will be able to figure out, you know what, I was able to figure out 3 bifurcations or 3 groups in this data. Although you were just giving all the information you have, but this system will be able to figure out that based on the information you fed me, I was able to figure out that this model can this data is divided into 3 groups, and one is the apple in this example, one is banana, and one is peach. So that's what unsupervised learning is. And then I'll go next, and you will see another example. So the thing is, when we are, so from here, just brace with me, because you know, bear with me, because you know, things might get a little I won't say tougher, but a little more techy. You know, now we are jumping into data sciences, and that's what data science is all about. You know, we are talking about algorithms. We have to select the problem we have, and then as algorithm we need to select. So first we have to figure out what's the problem we are solving, and what's the algorithm we have to select. Okay, so the practical demonstration that is going to come at the end of this presentation, I'm going to tell you what that practical is. So we are going to take a data of American Census survey. Okay, a data is there already. I just imported that data, and using that data, I will figure out that, you know what, I have a marketing campaign to run, and I want to run a marketing campaign to people who are earning less than 50,000 a year, or maybe to people who are earning more than 50,000 a year. Maybe my marketing campaign differs. Okay, so using an algorithm, I will check, you know, what are the people, if a person X might be earning more than 50 or earning less than 50. So I have to do this kind of a prediction for my marketing campaign. Okay, so that's my problem I'm going to solve. But to solve this problem, there are various algorithms in front of you. There are many algorithms. So I'm going to give you example of few algorithms, and then out of those few algorithms, I will select one algorithm, and we will actually do a practical demonstration on it. Okay. So one of the algorithm is called lazy learning algorithm. Okay. So again, like I told you, bear with me. This from here, we are actually getting into data sciences, and it's going to be with terms will be involved. Okay. So, but yeah, that's how it is. I try to lay it down as basic as possible, but still. So one of the algorithm is called lazy learning algorithm. So what you have to do is that you have to figure out, for example, a tomato is a fruit or a vegetable. Okay. So what you have is that based on historic data, you have all the characteristics of fruit and all the characteristics of vegetables in front of you. Okay. And then you give a model a tomato, and the tomato you'll figure out, which are the closest um, characteristics this tomato lies in. And based on your analysis, you figure out that, tomato is kind of lying in between in the middle of a fruit or a vegetable, but it's more inclined towards a fruit. So let's call it a fruit. Okay. So that's what a lazy learning algorithm is. Again, I am not expecting anyone, including myself, to understand lazy learning algorithm by just this one example. Okay. What I'm trying to tell you is that there is a process of selecting algorithms, and you need to understand algorithms, what they do, in order to pick the right algorithm for your problem. So that's what happens when you go to any university or any place where you will learn theory of data sciences. That's what they are going to teach you mainly. They're going to teach you theoretical understanding of different algorithms, and then when you will go into practicals, you will be able to figure out what is the problem and what was the algorithm you have to select. So again, it's not the goal to teach you what is lazy learning. I am just telling you that this is one of the algorithms. Another classification of algorithm is called probabilistic problem tongue twister for me. Pro, prob, Probabilistic learning. So you know what I'm saying. Cool. So it's just a tongue twister for me. Sorry for that. Okay. So what here happens is that you give uh, different dimensions of something to your model, and then ask your model, is it a butterfly? So based off the historic data, it will figure out that since I have been trained with many butterflies, I can tell you with 83% accuracy that this is a butterfly. And probability, the probability of this being a butterfly is 83%. A probability of this being a flower is 65%. Because you know what, butterfly and flower both have colors, both look good, both look elegant. But what is the probability that this is a butterfly and this is a flower? So this kind of probabilistic learning will actually give you an answer in probabilities that what is a butterfly and what is a flower. Then there's another form of algorithms, not just one algorithm, but forms of algorithm that's based on decision tree. Okay. So these kind of algorithms give you an answer like yes or no. That's what they do. Okay. So when you have to achieve an answer of yes and no, so based on your data, where, for example, there is a company who have done an analysis and they want to get to one answer. Are we giving them a loan or are we not giving them a loan? Simple, yes or no. Okay. Are we going to run a campaign for this person or are we not going to run a campaign for this person? Yes or no. Okay. If you have to reach that kind of an analysis, you use something like this, decision tree based algorithms. Okay. All of these things, decision, probability, and lazy learning, are the forms of what we call supervised learning. All of these things, which I showed you on these 3 slides, is basically done on historic data. Then we have something called unsupervised learning, and one of the famous algorithms on unsupervised learning is called k-mean clustering. What happens in k-mean clustering is that you just give it the data, randomly. You're just supplying it to data on runtime, and By analyzing this data, this algorithm will be able to figure out groups in that data. Okay, because you know what, when you are actually doing these kind of things in practical, and when we talk about data, this data is in millions. A naked eye or an Excel sheet even might not be able to figure out these kind of information in a data, that what are the different groupings in particular data. So this kind of algorithm, a k-mean clustering algorithm, will generate a cluster around the data, and then you will be able to, you know, group the data together and then reach certain decisions. So again, this is one of also the advanced topics we are not going to deal with it, but that's also was one of the algorithm. So next comes, now we are going to do a practical after this slide. And there are certain steps we have to perform in order to do a practical. The first step is always to gather the data. Okay, there will be data somewhere around, or maybe you have to go and gather the data. Let's take an example of a barber shop. If I have been doing some analysis on a barber shop, they might not give their data on the internet because they're a small business, but we still want to benefit them. Or let's say chai shai. I mean, I like chai shai. I mean, I might go there after Eid, you know. So I want to perform an analysis on their data. You know, they are taking orders and everything, but um, they they I might benefit them, you know, but their data is not available out there. So I'll get the data. I might call them, you know, can you give me authority or somehow access to your database, where whatever software you are using, I want to get that data. You know, it could be anywhere you can get data from. So you have to gather the data, and then in step 2 you have to prepare the data. So when we say prepare a data, what does this means is that um, we are preparing a data, and data might have some issues in it. I can give you one example of what a preparing might look like. Few uh, in Boston 3 years ago, I was working with biosensors. I was working in physics in biosensors. So there was a hardware team, and the hardware team was generating biosensors, and I was leading the software team, and I was working on the software side of things. And those biosensors were generating enormous amount of data. And when they were generating the data, we were collecting that data along with patient's history. And when we deal with the patient history, I saw that there were dates column in their data, and then people have written name in the date column. No, that's a problem. You know, how to deal with that, you know. So we sit together and figure out that, you know what, we have to write a Python script which will take out everything that doesn't look like a date, and will put in the names column, and everything which looks like a name but it's in the that date column, we have to shuffle these things, and we have to write a script to do that. So writing that script was actually a process of preparing the data. And there could be other things as well. You might have to split the data, or you might have to take out the noise from the data. When we were working there, when we were dealing with historical data, there was many things in it. There was a data which the year was 2 digit, like for example 23, and there was literally a person who was born in 1923, and he was alive when we were analyzing their data. So, but it was written 23. But what if we have to figure out it's 1923 or 2023, right? So we have to write a Python script to append 19 before everything that is 2 digit. So that was all preparing a data. And then we have to choose the model. Like to show you in previous example, we have different algorithms to deal with. So we have to choose a correct model for us. And then we have to train our data on that model. So all of these steps you are going to see in practical right next to this slide. So you train that model, you evolve that model. So what happens is that it might happen that, you know, you are training a model, but you are not getting good results. So you go back and maybe you change the model, or maybe you just add a different column in your data and then train your model again. Or maybe you were using a column which is not making sense. You take out that column and then train that model. So you keep on training that model until you get a good model to deal with. And then once you are done, you save that work you have done somewhere, and then later on you just call that work, and this work will give you the prediction. You call that work, This work will give you a prediction. So I'm going to show you all of this in the example. So we are going to get to practical of it. Any questions till now? Asking once, asking twice. We are going to the practical. So, okay. So up till now, what we were discussing was theory. Okay. Uh, when we talk about practical and we have to deal with data, there are many tools in the world which are very good with dealing with data. Excel is one of the most famous tool, and I'm pretty sure all of you who have joined us might have been interacting with Excel one way or the other. Might be when they were student, or might be a job, or might be in their university. They might have been interacting with Excel. Excel is a great tool. I mean, I mashallah know Excel, mashallah 0.003%. Okay. So Excel is a huge tool, you know. I mean, I don't know Excel. We play cricket, and I do cricket scores on Excel. You know, just use it as a tabular tool. But Excel is huge, you know. But still, you know, there are other tools that are really good in creating in dealing with data. One of such tool is developed by Microsoft, and they call it Azure Machine Learning, where Azure is Microsoft cloud platform, okay, and machine learning is like machine learning, so they call it Azure Machine Learning Studio. And what we are going to do is that we have a problem in hand, and we are going to solve that problem using Azure Machine Learning Studio. Okay, so what is the problem? So the problem is that there is an XYZ marketing company, and they want to run marketing campaigns based off person's income. Okay, if a person is earning more than 50,000 a year, they want to run a different marketing campaign. If a person is earning less than 50,000 a year, they want to run a different marketing campaign. So can someone unmute themselves and tell me what is the kind of an algorithm we should be using here based on the algorithm we discussed? Can someone tell me? Anyone? So it's kind of a Boolean decision. Either we're going to run the campaign or for them, or we might not run the campaign for them. Now, can someone tell me what kind of an algorithm we might be using out of these algorithms? We have this one.
Is
We have
that
this
the
one.
only factor?
What's it?
Is that the only factor, the income class?
We have to predict the income class, but there are many factors to it. But in the end, we have to reach a decision. Yes, kind of, you know, either we are going to run or we are not going to run a campaign. So can someone?
More like if you have some data, if you know where they lie, then it's a different thing. But right now, it seems like a logistic regression or maybe decision tree.
Yeah. So what we are going to select for this problem is something like a decision tree. Okay. So I am going to log in. I'm actually already logged in into Azure Machine Learning Studio. It's a tool, like I told you, given by Microsoft to deal with data. So I'm going to go to my experiments. Since I'm already logged in, so these are experiments I've already worked on. Few experiments was tested on something, but we are going to create a new experiment. Okay. So what they give us different templates. If you want to run experiments on images or blah blah blah. I mean, this is huge. Their library is huge. Maybe in experiments on airline industry and different type of experiments and forecasting experiment, blah, blah. But we are going to start blank. Okay. So we are going to start blank. Okay. So on the left side of this tool, so this is a tool which I was talking about. On the left side of a tool, we have different, you can say, tools in a tool which actually going to help us perform our experiment. Okay. So we have a data format converters. Like for example, our data might be in a different format and we have to convert it into a different format. We might have to get our data from something. We might have to get our data from a database or an Excel sheet or something. And then we might have to transform our data. There are different type of transform, median, filter, IIR. They're huge. Manipulation data, we might have to join the data, blah, blah, blah. It's huge. And then there are multiple machine learning algorithms. Okay. So we have one class 4 PCA based anomaly detection algorithm, multi-decision forest algorithm, multi-decision jungle algorithm, multi-logistic regression algorithm, neural networks algorithm. There are many algorithms which are here. And then the k-mean clustering is there, which I told you is one of the algorithms there. Regression is also one of the groupings of algorithms. So this is also one of different type of algorithms they have grouped together and called regression algorithms. So this is this is there. So again, what happened is that when you are learning a theory of data sciences, or let's say you get yourself enrolled into a school which teaches you data sciences, you will be actually learning about these theoretical concepts of these algorithms, all of these algorithms, most probably all of these algorithms. Okay, so this tool which is open in front of you is just a means to apply that theory, convert that theory into practical. So this doesn't mean that this is the only tool. There are many tools. There is one called RapidMiner, and then there are a few others I cannot recall right now, but there are many tools out there which help you to apply those theoretical concepts into practical. But the thing is, once you are learning the theory, it's 80% of data science is understanding the theory, understanding these models, how they work, and in what kind of a data they work. So you have to figure out that the problem I am dealing with, what is a suitable thing for that. So if we go to our steps, the first step is actually to get that data. So I have different forms of data in my system, and I am taking a data which is adult census income data. Okay, and let me visualize this data, what it looks like. So I just, again, purpose is not to show you how these tools work like. So if you're not following it, it's okay. The thing is, I'm just giving you a overview of what this data might look like. So I will click visualize, and this is how this data looks like. This data has 32,561 rows. It has 15 columns in it. Okay, and the columns look like this. We have age, work class, education, their status, marital status, occupation, relationship, race, their gender, and then their capital gain, capital loss, or hours per week they work, their native country, and income. So income is something we are going to predict, but this is a historical data. So can someone tell me it's a form of supervised learning or unsupervised learning? Anyone?
Supervised.
Supervised learning, because I always say that. So the thing is, it is unsupervised learning. Okay, so we are dealing with historical data. Okay, sorry, it is supervised learning. I got confused myself. We are dealing with historical data. It is supervised learning. Okay, so if we click on something, this tool is giving us different. If I click on age, this is a form of supervised learning. This is giving us that different range and age might vary. And if I click education, it is giving me different, like, there are high school graduates, bachelors, and everything. It is giving me different classification. And if I click, I'm so understanding data. So by clicking this,
I have a question here.
Yeah,
sorry.
sure.
How is this supervised learning data anyway?
This, because we are dealing with historical data, this data already exists.
But it does not dictate supervised learning, right? It's just data. It's plain and simple. Supervised learning would be a scenario where something happened actually.
So depend on what we are doing. So what we are doing is that, for example, if I am not sure that what I'm going to get from this data and what are the different classifications in that data, that will be unsupervised learning. In this case, I have a problem in hand. Okay, I have a problem in hand that there are column and I want to predict one column, and I'm going to predict it based on something already exists. That's why it is supervised learning.
Okay, got it.
And then if it's the same data, okay, not in a different data, same data, but our problem is different. Our problem is that, is there any classification in that data which we don't know right now? That will be unsupervised learning on the same data. Okay. So because of the problem we are solving right now, this is supervised learning. So this is the data. Okay, so I have a data in front of me, and then based on that data, what I'm going to do is that there were many columns in that data, as you remember. You know, all of these columns might not be, you know, suitable columns for my analysis. So what I'm going to do is that, and then what I'm trying to tell you that how a tool makes data sciences and application of data sciences concept easy to do. Okay, so I'm going to select few columns in that data. Okay, so I will take, so this is a block and this is a block. Input of this block is this block. Okay, so this red thing is not happy, means that the block is not happy. So I have to select some columns from it. Okay, so the columns I'm going to select, what again, the thing is, I'm not sure that the columns I'm selecting are the best columns, but that's where I told you that evolution comes. You keep on changing your model until you get a better understanding of the data. So let's select age for our analysis, and let's select education for our analysis. Let's select their marriage status, and let's select relationship, and let's also select race, and then also select their gender, and then also select their income. Okay, so let's select this information for our data. mm, you know, capital loss, capital gain, occupation. Let's assume that this data is not relevant for the problem we are solving. So these are the columns we are going to select. Okay, and then if I run this right now, what's happened till now, if I run this, and now if I visualize this thing, you'll see I just have the data I have selected right now. Okay, there's no other data in it, but all the rows are still there. All the 32,000 rows are still there, but I have now 7 data. So we are on a step which I told you that we are actually preparing the data. So there could be many steps in preparing the data. Like I told you, you know, data might be faulty, data might have noise. There are many tools in this tool which we can use to, you know, cleanse our data, or clean our data, or clean missing data. Like for example, this is something called clean missing data. What happened is that there could be some rows empty. So we have to tell what to do about those rows. Okay. So there are many ways you have to clean our data. We have to clean the data. So the next step is we have to select um, algorithm to train. So the algorithm we are going to select is called to class boosted decision tree algorithm. So this is an algorithm we are going to select. Okay. And then once we have selected this algorithm, again, I'm not expecting you to understand all of what I'm doing right now, but just go with the flow, and then you will be grasp few of the concepts. So now we have to pick up a trainer. So we are going to train our data. So So this is the algorithm we are going to select, and we are going to train our model. So how we are going to do is that we are going to train it like this. So when we are going to train our model, what's happening here is that just wait a second. So the thing is, there is a field. We have to give data to this training model. Okay. So part of this data is part of this data which we are going to train this model with, and then part of this data is where we are going to test this data with. Okay. So the thing is, we have to split our data into two things. One which will be required for training this model, and one which will be required for testing this model. Because remember, by just creating a model, we cannot tell that our model is good or not. We have to understand whether the column we have selected, or everything we are doing, is making sense or not. So then we have to split the data into two parts. Okay. So one part of the data will be used to get training, and one part of the data will be used to get testing, to do testing. So this way I have to split the data. So what I'm going to use is that another thing which splits the data. Okay. So remember this part, up till now we have all the 7 columns, and then we have all the rows in it, but we want to split this thing. So we connect this from here, and we are saying that 0.8%, 80% of the data will go on the left side of this split, and the 20% of the data will go on the right side of this split. So we are going to train our model using the 80% of the data. Okay, and we will use this part later. Okay, and then we have to tell which is the column which we want to predict. So I'll pick up the column selector, and I'm telling that income is the column which I want to predict. Because remember, our problem is that we want to run a marketing campaign based on their income. So the income is the column which we have to predict. So this is the setting I have done. So I'll start from the beginning. I already had a data set. I injected that data set in the system. Based of that data set, there were many columns in it. So if I show you again, there were many columns in it, but our problem might not need all the columns for their analysis. So what I did was that I selected few columns in that. Age, education, 7 columns I selected. Okay. Then in the third step, I selected an algorithm which I want to use to solve my problem. So the algorithm I selected was 2-class boosted decision algorithm. Okay. And then I injected a trainer. So a trainer is going to train itself on that algorithm, but a trainer also need a data. Okay. So what's going to happen is that out of those 32,000 plus rows, 80% of the rows will be used for training, and the 20% of the rows will be used for testing whether our training was successful or not. So that's what's going to happen next. So after this, I am going to actually score my model. So the thing is, there will be a result of this training model, and I have to check whether it is generating a good result or not. So I'll do that. And to score the model, this is the testing. So to score the model, I have to score the model against, can someone tell me what I will do now? It's quite obvious, but anyone? So data was split into 2 halves, 80% and 20%. I used 80% of the data to train the model, and I'll be using 20% of the data to test my model. So this 20% will actually come here. Okay, so based on this thing, I am going to score my model. Okay, and then at the end, I want to evaluate my model, that whether my overall overall system works or not. So what's happening here is that scoring is actually going to tell us that how well our model has performed. Okay, so that's what we are going to do here is that, and score knows that it has the data. If you just focus here for a second, at this point, score knows that it has a 80% of a data which it is being trained from, and it has 20% of a data which it has never seen before. Okay, based on this thing, we are going to test whether our data is good or not. So that's how well our model is performing. So that's what's the purpose of scoring model is, that we are training model on 80% of the data, and then scoring model, we are supplying 20% of such data to our system which it has never seen before. Okay, and then based on that, we are going to evaluate. So let's run this. So while I'm running this, what's happening is that it is using Microsoft Cloud's computation power to analyze this data, run this data, and do everything with this data. Okay, so while I've done this, let's see what our model looks like. So I visualize my evaluation model. Okay, so this thing actually gave me a curve. So I will explain this curve briefly. So the fact that this curve is on the left side, inclined towards the left side, tells me that this model, everything which I have done, was predicting. So if you recall, I have a training data and I have a testing data. So the fact that this curve lies on the left side gives me an idea that my model is a very good model, because it was able to predict almost with 90% accuracy against the test model, against the test data. So I had a trained data and I have a test data. And if you remember, in the test data, I had an income column there, right, in the test data. So the correct answer was already present in the test data. So when it matched the training data with the test data, it has 80% to 90% accuracy based on this curve that it was a good model. Can someone tell me if this graph could have lied on the middle? What could have that meant?
Inconclusive.
What?
Inconclusive.
Yes, kind of inconclusive. Like it would have given me an understanding that 50% of the time it was okay, 50% of the time it was not okay. So I might not use that model. I might have to go back, might have to switch some columns out, might have to bring in some other columns and do this again. Okay, it might not be inconclusive. And if this curve would have been all the way on the right side of it, it means that I have a very, very poor model. I had a training data and I had a test data. Whatever I tested was almost wrong. So can I use that very wrong model? A funny answer is yes, actually I can still use that model. What I will do is that I will get my prediction from that very wrong model and will do the opposite of it. So that is also something which is possible. And then it is also giving some other information. It is telling me that when I was testing this data, there were 887 true positives, that a person's income was greater than 50,000, and it was true, and it predicted it correctly. And then there were true negatives, that their income was less than 50,000, and 4,000 of the time it predicted it. And overall accuracy is 0.83%. And the precision is this, F1 score is this. I don't know what the F1 score is, but the thing is, once you are actually a data scientist, I mean, I'm not a real data scientist. So when you are actually a data scientist, all of these terms are going to make sense to you, okay? Threshold and everything. So this is a model we have created right now. So now the next step of this thing is that we have to save our model. We did some work, we have to save our model, and then so that we can reuse this model. So we are going to publish this model, whatever we have done, as something which all of the other people who have done, who do software development, like people like me. So I'm not a data scientist, right? So a data scientist have done their work, and they have published their work as a service for others to consume. Again, please don't mind if you're not getting this, but that's how it happens, that you data scientist, up till now I was having a data scientist hat. So being a data scientist, I created all this thing, and then let's say not a good data scientist, I mean, because I'm not into these things that much, but I created this model, and then I have saved this model, and I have to publish this model. Okay, so what I'm going to do is that I'm going to use the input of my service to the model which I have trained, and then in this model, yeah, there will be an input, and then I am going to remove the income from here. The thing is, I know that my model is trained now. Okay, so I'm not going to use income anymore in my training. My model is already trained, and I'm pretty sure that it will predict the income now because I have trained it. So I will remove this information from here, and then I will take the input of my service and give it to my score model and get an output. So I will run it one time. So it is running, you can see here, it is taking some time. It is using amazing cloud computation capabilities of Microsoft Cloud, and it has finished running. And then I am deploying this thing for the developers to use. So my job here as a data scientist is done. I have stored my information. I have stored my information, the work I did as a data scientist, and I took off the data scientist hat. and I give a service to the developers or anyone who want to consume this data, and then they can consume it. And how they can consume it, something like this. Okay, so you remember we had certain inputs. So I'm going to give an input of date. So okay, so I'm giving an input of a person which my which my model has never seen before. They have never seen it before. Okay, so their age is 44. So remember, at this point, my model is trained to do predictions, and we have checked that predictions are 0.80%, more than 86% correct. So using that model, now we are going to get an answer whether we are going to run a campaign for person X. So that's the answer we are going to get right now. So here we gave its age, his age. We have given its education. He might be a PhD, and we are giving its status, and then his relationship, and then its race, and then its gender. Okay, so based on the results which I provided, I gave it this result. I got an output. This is my output. Okay, output says that by giving this results, their income will be more than 50%, $50,000 per annum, and I have 0.90% trust on my accuracy. So this is a score which the model which I created is giving me a result. So I give him an input of a person which that model have never seen before. That input which I gave, this was the input. This was a person X or any random person. I gave its input, and my model told me that based on the previous data, based on the things I've already learned, I am telling you that there is a 0.90% chance that this person will have income greater than 50K. And now I can do a decision that whether will I run this campaign for this person or not. And same way I keep on testing this data for other people, and then I will come to my conclusions. So that's how the thing was. These were the steps. We gathered the data, we prepared the data, we choose the model, we trained the model, and then we didn't do as such hyper tuning. I mean, we could have done a bit of an hyper tuning. Like for example, I go back to my experiment. Let me close this. I go back to my experiment, which I just did, and then I figured out that, you know what, I might not need their status information. I might not need that, right? Maybe I'm tuning my data, right? And then I click run again and doing everything again, you know? So that is also one of the steps. The thing is, you can never say that you have reached a perfect model in the first attempt. You keep on checking a result and then going revisiting your model. You check a result, you revisit a model. You check a result, and after a lot of effort or understanding, then at some point you reach a very good model, and then it keeps on evolving based off the new data that is coming to it. So that was all about the practical. Any questions? No questions? Cool.
It's a bit unrelated though. Is any of this part of the Azure Data Scientist training track?
Azure, yes, it is.
Okay.
It's all about this. But yeah, let me answer your question like that. So the thing is, when Azure will be teaching you something about data sciences, they will be using their own tools. But one thing which always will be common, whoever is teaching you data sciences, is that the theory of it. And when I say theory of it, I was talking about these things, right? Just see, these things are a huge number, right? If you have to run a Python script, maybe there is something you cannot do. Maybe there is something you cannot do by just dragging and dropping something. Maybe you have to run a Python script. So you will see that whenever you enroll in something data science, they will ask you to learn Python. So what you can do is that you can execute a Python script. Like for example, if I want to execute a Python script on a data, I will do it like this. And then if I will write my script here, so this is Python language, you're coding Python here, right? So the thing is, when Microsoft will be teaching you something, they might be doing it in this tool, but it doesn't mean that if you learn it from Microsoft, you will not be able to apply this concept. Because um, learning a tool the way I have just done it, by dragging and dropping and configuring things, it is just literally the 10% part of data science, or yeah, maybe 5%. The thing is, you need to understand what is median filter, what is FIR filter, what is IER filter, what is threshold filter, what are these things? I mean, literally, I don't know what are these things, right? So just imagine there are many classification algorithms. Two class decision jungle forest, this is the one which we use, based algorithm, blah blah blah. There are many neural network algorithm, or I mean, that's what you do when you are learning theoretical data science. And once you are familiar with that, you can literally use any tool. There are many tools in it, in the data sciences world. But of course, when you go through Microsoft, they will be doing it through this tool. I hope I answered the question satisfactorily. Any other question?
Have you used any other like Google or AWS?
Yeah, I am pretty sure AWS have amazing tool, but like I told you, I've been more around Microsoft technologies since my university. I've been working in Microsoft technologies, and then it's mostly happens like this. Professionals are mostly into one of the other technologies. It's not that these things are not available in AWS. It might be more amazing there, but I personally haven't used them because it's just that I have always been into Microsoft shop most of the time. So yeah, but again, AWS and these technologies also have great tooling for data.
Mhm.
Any other question? Asking once, twice. Thank you so much, everyone. Hope I was able to clear a few of the misconceptions. But just remember one thing, that a career in data sciences, a goal is a goal should be to get that wow factor in you. You should be loving doing it. I'll say that you should be a data science. You should become a data scientist when you reach a point where you know what you would like, hungry about data. Yeah, please give me the data. I want to run this data and I want to do an analysis. And believe me, one decision is worth millions. And maybe if you have heard about, it's a conspiracy theory how Trump won his election. He got services from British Analytica, British something. Correct me if I'm wrong. So again, it's a conspiracy theory. I discussed it with one of my friends who is also in this call, France. Like, if you remember, we were discussing this thing, that British Analytica, gave analysis to Trump by doing data processing, and there is something called sentiment analysis. Okay, sentiment analysis service, sentiment analysis of theory, and there is a sentiment analysis service from different services. So if I show you what a sentiment analysis service might look like from Microsoft. So Microsoft is also giving you a sentiment analysis service. So you give it a text, it will tell you how much positive in it, how much negative was in it, was there vulgar language use, so it will give you a complete analysis of a sentence, and then again, if someone want to drop, they can drop. I mean, from there, I'm just going to show you something like really cool. So it's not related to data science, but related to data science, but something on how Microsoft make things easy, so easy. So I create a logic app, and what I want to do is that I'm creating a new logic app, and then let's call it. Uh, let's call it um, my logic app, and I'm using cloud, so I will deploy this app in central US. I will create this app, and then again, I'm not going to go all the way through this, but just giving you an idea how Microsoft does things in a really amazing, convenient drag and drop way, most of its things, so that it's really amazing to deal with. So I'm creating a logic app, and then I'm creating a logic app from scratch. And then I'm going to use a Facebook connector. So I'm going to use a YouTube connector. Let's use a YouTube connector. So I'm going to use a YouTube connector. Oh, let's actually do Twitter. Sorry, let's do a Twitter connector. Okay. So when a tweet is posted, so if I log in with my Twitter account, do I have a Twitter account? I don't know. Let's check. I mean, it will take some steps anyways. So what I will do is that I will log in with my Twitter account, and this connector is called when a tweet is created. Okay, I might not be able to show exactly how it will work, but what I'm going to do is that all of this thing is like you select another action, and maybe you want to do something on YouTube, and then what you can do is that you can fetch the text out of your Twitter and then perform a sentiment analysis out of it. And then a sentiment, sorry about that, I have to log in and give permissions and everything to be able to perform this thing. So let's skip that. But the thing is, we have services, and we can connect service from another service, and we can connect it to, a Vision API, or you can say text to speech service. So there are many services like text to speech and text analytics service. Okay, so I might be using a text analytics service, and then I want to detect sentiment of it. Okay, so that's what's happening. Something get posted on Twitter, and I use text analytics service, and I have to do something blah blah blah. And what will happen is that it will give me a report, how much positive was in it, how much negative was in it, how much violence was in the text, and all these things. So it will give me something like this, and then based on that, I might want to mail someone, so I will use Gmail, and then I want to send an email of the result of this text analysis to someone. Just imagine how quickly I solved a problem. So a problem I'm trying to solve is that if someone is using a filthy language on my Twitter page, I will do a text analysis and I will email it to myself just quickly. I mean, I'm not doing it all the way, but you can just imagine how Microsoft Word works. Okay, so all of this is dealing with data. So there was a Twitter, something was uploaded, a data was generated, and there might be a training model like our model. Someone might have trained an amazing model which could tell from a text that how much % of this data is violence or nudity or something like that, and based on that it generates a result, and I can email that result to myself, and I can ban that person. For example, if I am a group owner, I can ban that person, or maybe it is Facebook. So I mean, we can do wonders, my friends, with data. We can do wonders, literally. If I am so enthusiastic about these things that if I keep on talking, I can talk for days on these things. But literally, we can do wonders using Microsoft technologies. And I am a Microsoft. I might be biased for Microsoft technologies, but again, AWS and everything. I mean, the thing is that data can do wonders if you are able to analyze the data properly. So yeah, that's all I wanted to say. Any other questions? Thank you so much, everyone, for your time, and hope I was able to, give you something out of this. Thanks so much, and please keep me in your prayers. Pray for me, and then never stop learning. Thank you. Thank you so much.
Thank you. It was very informative.
Thank you. Thank you.